Hello. 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 Hi everybody, can you hear me? Can you see me? Hi Radha. Hello Arjun. How about now? Yeah, it's better, right? It's OG. It's original. Perfect. Okay, hi everybody. This is Bhavana Bisht, your educator for today, and this is me. Hi, hello. This is me live. Sorry for the bad lighting today. Yes, and that's my photo. It's so much of light in comparison to this. And also, I'll be your science educator for today. And today, what we are going to be doing is structures of the atom. Okay. So I know the chapter itself is structure of the atom, but today we are going to be talking about all the structures of the atom. Like how did we come to the final destination? How did we reach there? How did we know that yes, this is how my atom looks like? This is how there where my nucleus is in the center and I have orbits around it. How did we reach over there? Yes, that is what we are going to be doing today. Hi Arjun, this is for class 9th, and hi Raj Singh, hello, this is for CBSE class 9th, okay? And yes, if you have any doubts, if there is any variation in my sound or anything, please let me know in the live chat section. Okay? So let us study about the atoms, right? Now we all know that atom is the indivisible particle of matter. It is the smallest particle of matter. But who actually started giving us all these amazing ones, right? Electron is discovered by Thomson. And you know what? We are actually starting from Thomson himself. So Thomson was a British physicist and he was born in Manchester on 18th of December 1856. Now, he's a British physicist. That is great that you need to remember. He's J.J. Thomson. But what else? What is so amazing about him is that he received a Nobel Prize in the year 1906 for the discovery of electrons. Okay, so he received what? He received a Nobel Prize. What did he receive the Nobel Prize for? For the discovery of electrons. Is that clear? Very important to remember. He discovered electrons. Clear? Yes. Now, he was also the director of Cavendish Laboratory at Cambridge for 35 years. And the most amazing, and this part just gives me goosebumps, and that is 7 of his research assistants subsequently won Nobel Prizes, you know. So the approach that he had was amazing. Hi Arjun, we have already taken one session on mole concept last week. So if you just go to this channel, you will get this video. Okay, Arjun, so go and find it out. It is just taken last week. Okay. Now, okay, cool. Thomson received a Nobel Prize. He had 7 students, research fellows, who received Nobel Prizes. How? What? What did he do? So Thomson for the very first time said, excuse me, yes you, yes you. You know, my atom is like a plum pudding. Right, but most of us don't know what a plum pudding is. Okay, cool. Then lots. Plum pudding is very similar to a watermelon. Okay, in the sense not by taste or anything, but how in the pudding there are so many dry fruits that it is all incorporated into the batter very nicely. Okay, so whenever you take a bite of that pudding, you will get the nice cakey structure, and also you'll get the amazing dry fruits that are filled inside the pudding, right? So, and similarly how that happens with watermelon. So if you take a bite of the fruit watermelon, it is bound that you are going to get electrons, seeds into your mouth, right? So that is why the plum pudding model is synonymous with the watermelon. Clear? So Thomson was the very first person to give us this model. Okay, so what did he say? Okay, fine, we have a watermelon. What a hit. So he said, as how the fruit part of the watermelon makes up the whole watermelon, right? The pinkish part. But that is every time there is what? Lots and lots of seeds inside it that are marked by the black color, right? So he said that the whole pinkish part is my positive charge. If you are comparing watermelon to an atom, then the whole fruit part is the positive charge, whereas the seeds that are embedded into the fruit are my electrons, and that is how exactly my atom is present in nature. Okay, this is what he said, that this is how we get atoms in nature. Okay, so we have the whole big area of positive charge, and electrons are just negative charges are just embedded into that area. Yes, people were like, okay, so what did he exactly propose? Did he just give us watermelon? No. So he proposed that an atom consists of positively charged sphere and the electrons are embedded into that sphere. Yes. Then he said the negative and positive charges are equal in magnitude. So their numbers are absolutely equal. So if I have negative and positive which are in the same numbers, don't you think we are going to cancel them each other out? Yes, and as a result, the whole atom together is absolutely neutral. Yes. Amazing. So he explained that Thomson atoms are electrically neutral. But there was a drawback. Okay. And what was the drawback? We'll get to know now. Yes. So the second amazing person, the most amazing person who is beyond mind blowing, and that is Rutherford. Okay. Because what did Rutherford do? Yeah, Rutherford is just, below me. Can you see that man? Yeah, yes. With white, grey, green mustache. Yeah, that. So Rutherford was born in August. Yes, I don't know why it is going automatically ahead. Okay, cool. So he is called as the father of nuclear physics. Hi, Rashi Sabu. Hello. How are you doing? He is not only famous for his work on the model of the atom, but he has done amazing experiments on radioactivity, and he has also received a Nobel Prize in chemistry in the year 1908, right? So Thomson received a Nobel Prize in the year 1906, and Rutherford received a Nobel Prize in the year 1908. Is this clear, everybody? Yes. Now let's find out what exactly did he do. So Rutherford was like, okay, I get to know, I want to know that how exactly is atom made up of, right? So for that, what do I need? I need a sheet which is made up of atoms. And he was like, okay, everything in this world is made up of atoms. So what do I do? Okay, so I need something so thin that there are not many atoms overlapping each other, right? So he selected a gold foil which was as thin as he could make, right? And the gold foil was only about 1,000 atoms thick. Only 1,000 atoms thick. Then he was like, okay, fine, I got this. Now, how am I going to know what is inside it? Am I going to be like, knock, knock, and the atom is going to be like, who's there? And Rutherford will be like, I want to know, who are you? How many people do you live in one house? Does anybody give out that information? No, that's private, right? But Rutherford was like, if you want to progress in science, I want to know it. I will have to know it. So he was like, okay, cool. You know what? I'm going to use alpha particles. I'm going to use radioactive alpha particles. But the question is, from where will we use this alpha particles from? So he used, okay, fine, okay, cool. Then I'll use helium. I'll use helium ions. Yes, and alpha particles have a mass of 4u and they are very fast moving and have a considerable amount of energy. Yes. Now, on the assumptions of Thomson, he was like, okay, so if it is fully positive, they are all going to just bombard back. Nobody, not many will be able to go through. Like, he had some assumptions in his mind. Now, let's see that he expected alpha particles would be deflected by the subatomic particles in the gold atoms, right? Because alpha particles are much heavier than protons, and we know that we have large number of protons, so he did not expect to see large deflections. Now, let's see what he actually saw. Okay, this is how the setup was for Rutherford's atomic model. Here you can see a radioactive source, that is the helium nucleus ions. Yes, now I cannot keep a radioactive material just saying hi to everybody, right? It needs to be covered. So it was kept in a lead block. The helium alpha particles were bombarded onto the gold foil. Yes, and as soon as they bombarded into the gold foil, he saw that most of them directly went through the gold foil, and he was like, huh, what just happened? Okay, cool. So he was observing. Yeah, he saw most of them directly pass to the gold foil. Some of them, very few of them, had small deflections, as you can see, very small deflections, and 1 in 12,000. 1 in 12,000 deflected back to almost 180 degrees. Yes. So this is how it looks like. Alpha particles are going whoop, 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 whoop. And out of all these, only one goes back. Yes. Yes. Can you see? One goes 180% back. And most of them are deviated only by small angles. Yes. Now let's see what exactly were the observations that were made. Most of the fast-moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by small angles. Okay, surprisingly, 1 of every 12,000 appeared to rebound. Yes, yes, Raj Singh. So, and Rutherford was like, it feels like the gold foil was only 1,000 atoms thick. So he said it feels like the 1,000 atom gold foil is like a tissue paper. Yeah, and the alpha particles that I'm bombarding onto the gold foil, it looks like it is a bullet that is going and hitting, right? And after it is hitting the tissue paper, rather than tearing it apart and going ahead, it comes back and hits you. That is how incredible it was. So, what was the last conclusion of Rutherford's atomic model? He said that as most of the alpha particles directly went through the gold foil, he said most of the space inside the atom is empty. The keyword over here is empty because the alpha particles pass directly through the gold foil without getting deflected. Now, very few got deflected from their path, right? Indicating as alpha particles are very heavy, more heavy than the positive particles, he said, as only few of them got deflected from their path, it means that the positive charges are occupying a very less space. Okay, then a very small fraction of alpha particles were deflected by 180 degrees, right, indicating that the positive charge mass of the gold atom was concentrated in a very small volume. Yes. So these are the three features of Rutherford's model of an atom. Okay. So he said there are positively charged center in an atom, and that is called as the nucleus, which was not known earlier to anybody. That the electrons are present, but they are revolving around the nucleus in orbits, in well-defined orbits. Yes, and the size of the nucleus is very, very small in comparison to the size of the atom. Clear? So these are the three amazing features of Rutherford's model of an atom. Clear, everybody? Do we have any doubts till here? This is a quick revision session. Hi, Abhijit Kumar. Hello. Ready? Let's move on. So, was everything all good about Rutherford's model? No. He failed to explain one important thing, and that one important thing was, okay, fine. If you and me, we are asked to go about a ground, okay, let's say this is a playground, and if somebody asks me, you have to go to this ground 10 times, and you'll be like, huh, how am I going to do that? And when you start, after 5 rounds only, you're like, I cannot do anymore. I'm so tired, I cannot go any further, right? Similarly, if my electron is just moving in this circular orbit, moving and moving and moving, so it is going. So it is also going to lose its energy, as we lost our energy while going to the playground, right? So even my electron will lose energy. Now, he is not some very godly particle or not. So he is going to lose energy, and as we lose energy, don't we reduce our speed? Yes. We'll be like, we will cover the playground, but we'll reduce how much we are actually covering. Yes. So this also does the same. Electrons also does the same. So if electron is also doing the same thing, don't you think if it is losing all its energy, and it will finally collapse into the nucleus? If I tell you, go and make 20 rounds of the park near you, you'll be like, after doing 20 rounds, you won't be able to stand up. Similarly, if my electron is moving in orbits, so after some time, it is bound to lose all its energy. And once it loses all its energy, it is going to go and collapse into the nucleus. So if that happens, it means that atoms are very unstable, right? But once we look at the objects around us, we don't see the instability of the atoms with our eyes. It means that in nature, in actuality, the atoms are very stable. So why is this assumption wrong, right? So here comes our next superhero in this chapter. Are you ready to meet the next superhero? Are we ready to meet the next superhero? Hi, Parvati. Hello. Hi, Harsh. All clear. Very nice. Hi, Tanimapati. Hello. Okay. The next superhero was Niels Bohr. Yes. He got a Nobel Prize for his work on structure of the atom in the year 1922. Let's see, what did he say? So he said, yes, you're absolutely all right. Okay, you are absolutely right that electrons do revolve in orbits, right? But there's a very major information that while they are revolving in orbits, they are not radiating any kind of energy. And hence they are able to revolve in that orbits forever and ever. They are not going to collapse into the nucleus. Is that clear? Is that clear, everybody? That is exactly what Bohr said. So these are all the three important structures that were given to us of atom before we came up to the final structure that we all know today, that in the center we have a nucleus which is filled with positively charged particles, that is protons. Then there are shells, which are the K shell, the L shell, M shell, and N shell, and they have their own capacity on how much electrons that they can take, right? So to come to this, we have to go through all of that. Hi Arjun, when is the next Menti? The next Menti is going to happen on 26th. The Menti on structures of atom is going to happen on 26th. Now, what is the electronic configuration of what? We have not discussed any element, right? So, depending on the element that we will have an electronic configuration. Yes. Okay, so if you are a person who wants to attend sessions like these, one or full sessions, so you can download the Unacademy app where I take sessions every day. And this week, that is from 23rd February to 28th February, I'm taking sessions every day at 3:30 p.m. for CBSE class 9th. Okay, so if you want, you can, if you wish to join us, you can download the Unacademy app and I'll see you there. Yes. Also need an invite code. So the invite code is given down below. Hi, Ayushi Gupta. Hello. What is the electronic configuration of sodium? Okay. So what is the capacity of K shell? The capacity of K shell is 2 electrons, right? What is the capacity of L shell? The capacity of L shell is 8 electrons. The capacity of M shell is 8 or 18 electrons. N shell is 32 electrons. So in sodium, I have 11 electrons, right? So if I have 11 electrons, how many electrons can go into the K shell? Only 2 can go, right? So 2 electrons went into the K shell. So how many can go into the L shell? Only 8 electrons can go. So take this, 8 electrons go on into the L shell. So how many electrons am I remaining with? How many electrons am I remaining with? Only 1. So 1 electron goes into the M shell, right? So when you distribute the electrons in all the shells, depending upon their capacity, you get electronic configurations. That is 2, 8, 1 for sodium. Understood? SPDF are all these suborbitals which are present in K element respectively, but that you don't study in 9th standard, you'll be studying that in 11th standard. Okay. Also, if you want to have amazing poll sessions with amazing revision, do not forget to join me on unacademy.com. That also Unacademy live app which you can download in your mobile phones and use the code BBLIVE to invite yourself in. Yes. And I'm taking sessions every day from 23 to 28th of February at 3:30 p.m. Cool? Okay. Yes. So I know you all guys want one destination to crack your 9th standard and your 10th standard board examinations, right? And Unacademy is the final destination. So if you want to achieve everything, you can join us on Unacademy Plus subscription with a flat 10% discount, and 10% discount is only applicable till 28th of February. So if you are thinking of subscribing, the right time would be now. So use the code BBLIVE10. Don't forget. Okay, and also Unacademy has launched as amazing feature, and that is Unacademy Ask a Doubt feature. One of my favorite features, actually not one of mine, but the absolute favorite feature of mine, because you can ask unlimited doubts at any point of time. You get amazing video solutions with high video quality. You get exact matches for your questions. And you get assistance in your homework. What else do we need? Yes. So how to do that? So for Ask a Doubt, you have to go to your profile. You'll get an option in question mark, Ask a Doubt. Click on that. It will say, hi, whatever your name is. Take a picture or choose from gallery. So you could have already taken a picture in your gallery, or you can take the picture on the spot. Once you take the picture over here, as you can see, yes, select the picture if it is in the gallery, or click the picture if you're just clicking it right now. Now I know it may be like you have all the doubts in the world, but always remember, put your doubts one by one. Okay, because it is an app which is working for you. So crop the doubt, crop the question, the one question which you have your doubt in. Select the subject which it belongs to: mathematics, physics, chemistry. Yes, and as soon as you select that, you are going to receive your solution very, very soon. Okay, understood? And also, as I told you, if you are planning for an academy subscription, it is totally worth it. Why? Because everything you get to learn from the comfort of your houses, you just stay at it and inside your house, and all the things, especially in this situation that we all are facing, it's all available to you at one place. We have top educators to all over India. Regular doubt solving sessions and answer writing practice sessions are done whenever you need it, especially during the exam point of time. You have your own mentorship and guidance. For every session, you get a PDF material, so your notes are sorted. And also, we have a live test series. So, voila, nothing else. Yes, Raj Singh, I have a class tomorrow, not on YouTube. YouTube, we have a mentee quiz. YouTube, we have a mentee quiz on 26th. Okay, on 26th of February, we are going to have a mentee quiz on the topic that we have discussed today. But special class, that is the free live class, is happening every day from 23rd of February to 28th of February. Okay, these are special free live classes that I'm taking from 23rd to 28th of February. So you have to invite yourself in. So use the code BBLIVE10 as the invite code. Okay, then and only then you can attend the free live classes. Okay, this is the plan for Unacademy subscription. So you have 12 months. Do not forget that this is 15,000 only, and if you use the code BBLIVE10, you're going to get a 10% discount only in the month of February. Okay, only in the month of February. So what are you waiting for? Unacademy also has amazing iconic subscription, and if you're wondering ये क्या होता है, so over here you get your own personal mentor. Yes, somebody just assigned for you. So you get all your concerns absolutely solved. You have a live doubt solution session where your doubts are solved within 48 hours by a person present in front of you. Until you don't understand, it is going to be taught to you. You get your weekly report card. Your parents are updated about how you're doing. All of their concerns are answered, and you also get a study planner. So मतलब तुमको कुछ नहीं करना है, तुमको बस बैठना है and पढ़ाई करनी है, and everything else is done by Unacademy just for you. So subscribe to Unacademy Iconic. Okay, so this is how the iconic plan goes. Again, if you use the code BBLIVU10, you're going to get a 10% discount. Okay. No, structure of atom is present in CBSE class 9th. And also, as I told you, if you are planning on buying a subscription, this is the absolute right month, because for only for the month of February, we are going to get 10% discount. Okay, so don't forget to use the code BBLI10. Also, always there are revisathon running, so keep your ears open, because your whole syllabus is revised within 5 days. And if you have anybody, your neighbor, your dada, your siblings who is in 10th standard, do not ask them to compete for Unacademy Combat, the amazing, the most biggest scholarship of all times, because here your 50 winners are going to get CBSE class 11th scholarship. Okay, yes. So guys, download the Unacademy app today. Use the code BBLIVE to invite yourself in for all the free live classes, and I will see you on Unacademy free live classes tomorrow at 3:30 p.m. on Unacademy app. Okay, so I'll see you on Unacademy app tomorrow at 3:30 p.m. Till then, goodbye everybody. Please take care of yourselves, and I hope you enjoyed the session. I hope you enjoy this session, and I'll see you next time. Till then, bye-bye. Please take care of yourselves. And if you are going to school, please do not take your mask down, okay? Please do not take your mask down. And if you understood everything that we did over here, so please do not forget to give this video a big fat thumbs up. That is a big fat like. and comment and share with your friends who are in a search of revision. And I'll see you tomorrow at Unacademy Free Live class. That is at 3:30 p.m. tomorrow. Okay. Till then, bye bye, everybody. Please take care of yourselves and remember, prevention is better than cure. Okay. So wear your mask at all times. Bye bye.